Bismillahirrahmanirrahim. Now we are starting the mechanics of practical of engine mechanics ME101 experiment number 1 to study Vernier caliper, take different type of measurement and study different type of errors. Vernier caliper, it is an instrument that is used to measure the length of a and diameter of a cylindrical object and capacity of tube up to accuracy that is 0.05 millimeter consection. It is consists of main scale and a graduated vernier scale. Consists of 20 divisions, which slides over the main scale. It has two jaws, upper jaws and lower jaw. Upper jaw is used to measure the inner diameter of any object, and the lower jaw is used to measure the external diameter and length of the object, and the back strip is used to measure the depth of the object. Vernier constant and least count. It is the smallest measurement that can be made with the help of Vernier caliper. It can be defined by the formula least count equal to value of smallest division on main scale upon total number of division on Vernier scale. The value of smallest division on main scale is 1, and the total number of division on Vernier scale is 20. That's 20.05 millimeter. The least count of our said Vernier caliper. Zero error. If zero of the main scale does not coincide with the vernier zero, it is said that vernier has a zero error. It may be positive if the vernier scale zero is on the right of the main scale and negative when the vernier scale zero is on the left of the main scale. Now we will start how to take the readings. Measurement for length. Bismillah Rahman Rahim. Now the procedure to taking the measurement for the length of any object. This is our Vernier caliper. These are the upper jaws used for taking the inner diameter. These are our lower jaws used to take the outer diameter and length of the object. This is the locking screw. This is our vernier scale, comprises of 10 divisions subdivided into further half. It means 20 divisions on vernier scale. This is our main scale. Each scale is divided into one division, 1 millimeter scale. That is our depth gauge used to measure the depth of the sliding strip, used to measure the depth of the object. Now we want to measure the length of any particular object. Suppose we want to measure the length of this. So we hold the specimen like that, okay, by opening the. Now we lock the locking screw. Now the object is locked. Now for the main scale reading, we observe that the zero vernier is coinciding or crossing the which line of the main scale. Here as we see, it is crossing the 41st division. So main scale reading is 41 millimeter. Now for vernier scale division, we observe that which division of vernier scale is best coinciding with the main scale. As 20 divisions are visible for you, and here we see the division which is marked 1 is best coinciding with the main scale, but it is the second division. So the second division may be multiplied by the least count 0.05. It comes out to be 0.01 millimeter. Now the total reading will be main scale reading plus vernier scale reading. That is, the vernier scale reading is 0.01 millimeter and main scale reading is 41 millimeter. Add up 41.01 millimeter will be total reading for the corresponding object. Now we take the 3 readings for the length. Now we will take the reading for the diameter. Now we are start to take the readings for the diameter. We are taking the inner dia. Insert the object here and open the jaws. and now lock the locking screw. It is locked. Now for the main scale reading, as we see, the zero of the vernier scale is crossing the 13th division and not crossing the 14th one. So the main scale reading will be 13 millimeter. Now for the vernier scale reading, we observe which line of the vernier scale is best coinciding with the main scale. As we saw here, it is the 6th division mark line which is best coinciding, and 7th is also, but the 6th is the lowest value. It means the 12th division is coinciding. 12 multiplied by least count 0.05 will be 0.60. So the reading will be 13.60. Now we will also take the 3 readings. Why we take the 3 readings? We open the jaws, release the object, inner hole is there. Okay, now insert the object again and lock the locking screw, and again we observe, now it is also again the main scale is 13 as in the previous reading, and the vernier scale we observe is 6 is slightly missing, the 7th is obvious clear. So we will take the 7th division, it is 14th division. 14 into least count 0.05, 0.70, it comes out to be 13.70 main scale plus vernier scale reading. Again we take the third reading and take the mean of it. Why we take the mean? Because we take the average value of the reading. Now we want to take the depth of this object. As you see, the depth is very deep, so it will be measured by the depth gauge here. We open the depth gauge and insert it here in the object and slide from the top. Now it is fixed. Okay, now we are going to lock it. That's our reading. Now we read the reading. Reading is fixed because we have locked the reading. Now we read the reading. The main scale is at 36 and between 36 and 37. So it may be taken as 36 millimeter. As you see, main scale reading. The zero of the main scale is coinciding. Main scale is between 36 and 37. So we will take 36 millimeter. And now for the vernier scale reading, which line is best coinciding? I think 4.5. It is the 9th division. So 9 multiplied by 0.05 is 0.45, and 36.45 will be total reading for the depth. Why the depth is lesser than the length? Because it is, as you saw, the hole is taper. It is out injected inside, so that when the depth gauge strike with the upper jaw, which is in the cap, so the reading will be reduced. So we take the 3 readings also for the depth gauge, for the depth, and we take the mean of that. In that sense, we will complete our set of readings for 3 readings for length, 3 for diameter, and 3 for depth, and take the mean values and write down in the column for the results as in the workbook given to you. Hello students. Now as we show into you in the demo video how to take the readings of length, diameter, and depth. Now how to measure, fill the chart, observation for length. The main scale reading comes out to be 41 millimeter as we show you. So write down 41.00 here. The vernier scale reading, what would be here? It comes from 6 division, 6 into multiply by least count, 0.05. It comes out to be 6 division, it means it will be 12 division. 12 into 0.05 is zero point 0.6. The total rating will be 41.6 millimeter. We repeat the reading 3 times to take the mean value of the length. Now for the diameter, we measure the inner dia. The inner dia main scale reading comes out to be 13 millimeter. We are right down in the main scale reading column. The vernier scale reading comes out to be 6. It is a 12 division. 12 into 6.05 least count. It comes out to is 0.60, and the total reading with 13.60. Now we take the second reading. It the main scale is also 30. The vernier scale is 7. 7 to means it is 14 division, and 14 multiplied by least count 0.05 is comes out 14. So total reading will be 13 14 into 0.05 is 0.70. 14.70 will be the second reading. You will not take the third reading and take the mean value of the three readings. Now fill the column for depth. We measure the depth. The depth comes out to be main scale is 36. The vernier scale, what will be the reading? You note down here, multiplied by the two divisions and multiplied by least count. The value will be 12 division into 0.05.6. So 36.60 will be your reading. Take two more readings and fill it in your observation column. So in this way, we are going to cover the observation chart. After that, now there is some questionnaire. Take the mean value of length of diameter and depth. Write down here in millimeters. After that, there is some small questionnaire for you. In the next page, some questions. What is the accuracy of the Vernier caliper? The accuracy of Vernier caliper is the least count. What are different type of measurement that can be taken with the help of Vernier caliper? Inner dia, outer dia, length, and depth will be taken from the help of Vernier caliper. What do you mean zero error? It is written in your workbook, and I explained to you what is meant by positive and negative zero error. It also given to you concept. So write down the answers there briefly, and that will cover the first experiment. Thank you.